Question 11a. Find the equation of a line that passes through the origin. You know what the origin is? 0, 0 point on your graph, and the point of intersection of the lines. That's the point where these two lines meet. Lines x plus 2y equals 7 and x minus y equals 4. This is quite a straight question, but it requires a good knowledge of the topic. Where we'll talk about lines on a graph, equation of a line, midpoint of a line, and the likes. When we're asked to find the equation of a particular line, that's like saying y minus y1 over x minus x1 equals the gradient. Now what we need to find the gradient, and we need at least a point with two coordinates on that line. So find the equation of the line that passes through the origin. That's x is 0, y is 0, and the point of intersection between these two lines. That's the point of intersection between these two lines is just solving for the value of x and y. When you solve this equation simultaneously, you get a point with two coordinates, the x coordinate and the y coordinate. That's also a point on the line, and that is required to find the equation of this line. Remember, like I said earlier, you need the gradient of the line and at least a point on the line to find the equation of the line. For the sake of understanding, we're going to illustrate this information or this question so you can better understand when you're solving, because understanding how this works is going to help you better understand the topic. And you should also know that the illustration is not the actual graph, it's just to show you what the question is saying. Now let's go on to illustrate. Let's say we have our graph, and that's our x and y axis like this. It says find the equation of the line that passes through the origin. This is the origin where we have our 0, 0 point. Now that's the origin. Now, and also passes through the point of intersection of line x plus 2y equals 7 and x minus y equals 4. Let's say we have the other two lines, not the actual lines, but for the sake of understanding of what we're doing. Now let's take this as our first line. This is x plus 2y equals 7. No, this is not the actual line, but for illustration's sake, we're just trying to show what the question is trying to say. Take our first line like this. Don't mind the line is not perfect. Just take this as x plus 2y equals 7. Then the other line, note, is not the actual line. The second line goes like this, which is x minus y equals 4. So we have our two lines. The question says find the equation of the line that passes through the origin. Now it passes through this point 0, 0. All is saying that the line passes through this point here, and also through the point of intersection of these two lines. This is where they intersect. So at this point you can find it using simultaneous equation to solve for it. The line to be found is about to be shown. Now the question says find the equation of the line that passes through the origin, which is this point here, and also the point of intersection of these two lines. So this is the line we've been asked to find. We've been asked to find this blue line, and to find it we need to find the value of x and y at the point of meeting or intersection of these two other black lines. Now to get that, we can do that like I said earlier using simultaneous equation, and the point of origin, which is 0, 0, is already given to us. So we already know that's a point and this is another point, but we need the gradient. There's no way of finding the gradient from these other two lines than to use the point at which they meet, because they didn't use the word parallel to any of the lines or perpendicular to any of the lines. And apart from finding our gradient through the terms like parallel, perpendicular, you can also find it using our gradient m equals y2 minus y1 over x2 minus x1. We're not doing that now because although we have a point on it, as we can name that point our x1, y1, which is point 0, 0. X is 0, y is 0. But another point on that line is this point that can be deduced from finding the value of x and y of these two. That is the point of intersection of these two equations simultaneously. We know to get our gradient we need 2 points, 2 coordinates each. We need to get the gradient of this line, and we can't get it easily because apart from sharing a point at which these two lines meet, there's nothing linking this line to any of these two lines as regards being parallel or perpendicular. So we need this point. To get 2 points on this line, then find the gradient. We've gotten a point to be 0, 0, that's the point of origin, and the second point is the point of intersection of these two lines. That means we have to find x and y of both lines simultaneously. So we'll take the first one as equation 1 and second one as equation 2 and we'll solve. So we'll take the first one, x plus 2y equals 7 as equation 1. Then x minus y equals 4 as equation 2. Then we'll solve the simultaneous equation to find both the value of x and y. We can solve using elimination because it seems easy, because the value of the coefficient of x in equation 1 and in equation 2 are the same, as both are plus 1. If you have plus 1 and minus 1, you still have to make sure the signs are the same before you solve, so we can just subtract. We have x minus x, that's 0, you can put a dot here. Then you have plus 2 minus y. Note, most students will get this question wrong because of this minus. So you have two minuses. So it's like saying you have 2y or plus 2y minus y. Because this y owns this minus. It's like saying the coefficient of y here is minus 1. Although the 1 is not written. You don't just throw away the sign in front of it, particularly when it's negative. It's very dangerous in math. So it is plus 2y minus y. You have it as 2y, then minus, two negative signs together. You have to equate it to 1, that's plus 1. Minus times minus, or minus will give you plus y. And this is also saying 1y. So we have it as 2y plus 1y will give us 3y. So this is 3y plus 3y. Some students might jump on it and get it wrong. They'll just say 2y minus 1y, they'll get 1y. But actually it now turns into 3y. So note this. Is equals to, on the other side we have 7 minus 4. Since the 4 has no minus, so you don't need to be extra careful. So 7 minus 4, your calculator is 3. Since we are looking for y, we divide both sides by 3. 3 here 1, 3 here 1. 3 will cancel out 3. 3 here 1, 3 here 1. Y equals 1. We know the value of our y is 1. Then we can find our x. Now that we have our y to be 1, we can find our x substituting the value of y equals 1 into either equation 1 or 2. Equation 2 looks easier to work with. So we go with x minus y equals 4. We know our y is 1. When y is 1, we just substitute the value of y into the position of y. So we have it as x minus 1 equals 4. Next we do x equals 4. You know, we're looking for x, so we'll take this minus 1 over the equals to sign to find the value of x, to make sure x is on this side alone. So we have a 4 plus 1. X equals 5. The value of our x is 5. So what it's saying is, at the point of intersection, the value of x is 5 and y is 1. And like we write it as a point, we write the value of x first before the y. So we have it as our second coordinate at the point of intersection of the two lines given to us as x is 5, y is 1. And remember, from the upper part, we knew that that line that we're looking for, the equation of which we need to find the gradient first, also went through the point of origin, which is 0, 0. So another point is point 0, 0. The second point is 5 and 1. So the new line crosses the point 0, 0, and also x is 5, y is 1. And with these 2 points, we can find our gradient. Going back to our graph, this is one of the points on the new line we're asked to find the equation of the line for. So at point 0, 0, the second point which we calculated is 5 and 1. That's x is 5, y is 1. And with this we can find the gradient. Remember, we wrote the formula for the gradient at the very beginning, which is gradient m is equals to y2 minus y1 over x2 minus x1. Let's take the point 0, 0 as our first point, which is x1, y1, and 5 and 1 as x2, y2. Like we said earlier, x comes before the y, so we have it like this. So we'll use this formula to solve. We have y2 minus y1. We have our y2 as 1, our y1 as 0. So we have our gradient m equals 1 minus 0 over our x2 is 5 and our x1 is 0. So we have 5 minus 0. which is equals to 1 minus 0 is 1, 5 minus 0 is 5. So the gradient of the line is 1 over 5. Remember, the question says find the equation of this blue line, and the formula to find the equation of the blue line is y minus y1 over x minus x1 equals m, which is the gradient. We know we have our gradient, and we have 2 points on the line, which is 0, 0, 5 and 1. We can use any of these 2 points to find the equation of the line. It's going to give you the same answer. I think we're going to use both of them to show that you get the same answer. So let's start with the first one. Let's start with this one with actual numbers and not 0, 0. Let's see what we get. So we have it as y minus, our y1 will be the one at the back. The y in front means you don't put any number or numeric value for the y, you leave it as y. And now y1 here is 1 over x1 here is 5. X is always before y. X first, then y at the back. So we have it as x minus 5 equals, our m is 1 over 5. Now here we cross multiply. We have it as y minus 1 times 5. Be careful here. 5 into open bracket y minus 1. Be very careful here. This 5 affects everything on this upper part, which is in numerator, which is y minus 1 equals, anything on the other side times 1 is that number. So x minus 5 times 1 is x minus 5. We can still leave it in bracket. So we have 5 times y is 5y. Then 5 times minus 1 will be minus 5 equals x minus 5 times 1 is x minus 5. So we'll try and make y subject of formula to create our equation. So we have it as 5y equals x minus 5. Then this minus 5 crosses the equals to sign and becomes plus 5. So these are like terms. Minus 5 plus 5, owing 5 you have 5, it gives you 0. So 5y is equals to x. Since most times when they want to make equation of a line, they always make the coefficient of y 1. You can as well leave your answer as this anyway, but for assurance sake or to get your perfect score, you can divide both sides by y. So your y, 5 cancels 5, will equals x over 5. Using the point 0, 0, let's see if we get the same answer. We know our answer is actually y equals x over 5. Let's see if we get the same answer using this as our x1, y1. That's point 0, 0, the point of origin. This is x1, y1 now. Let's see if we get the same answer. And noting that our gradient m is 1 over 5. To find the equation of the line, we have it as y minus our y1 is 0 over x minus, our x1 is also 0 equals our gradient, which is 1 over 5. At this point, you don't get confused with this. Like y minus 0, what's y minus 0 and what is x minus 0? You can put actual numeric values to get what you get when you have this kind of questions, like saying 3 minus 0, which will be 3, 2 minus 0 will be 2. Whatever number minus 0 will give you the actual number. So note that and use that in solving the question. So with that understanding, y minus 0 is y over x minus 0 is x equals 1 over 5. No, we can't leave it in fractions like this, so we cross multiply. So we have this times this and this times this. That's saying y times 5 is 5y equals x times 1 is x. And since we don't want to leave our y with a coefficient other than 1, we divide both sides by 5. 5 cancels 5. You have y equals x over 5. The same answer using the second point. So either way, you still get the same result. For a quick recap or a summary of what we did, it says find the equation of a line that passes through the origin and point of intersection of the lines x plus 2y equals 7 and x minus y equals 4. To solve this question, we need the gradient of that line and at least a point on that line. We have a point already, which is the point of origin 0, 0. But we can't get the gradient without getting the second point, which is the point of intersection of these two lines. That's why we're given these lines to help us get that second point on the line. Then use both points to find the gradient and use any of the points and the gradient to find the equation of the line. Using the formula y minus y1 over x minus x1 equals m, then we get the equation for our line.